start at the beginning?
So I've already gotten 1 through 6, so 7 would be good to start at.
Okay. Let's go to 7. Sketch the solution to each system of linear inequalities. Okay. Well, let's graph that on number 7. How do I graph x is greater than or equal to 4? What's x equals 4 look like?
So that
Remember, x equal numbers are vertical lines. Y
right.
equal numbers are horizontal lines. So when you look at an inequality, our first goal is to figure out how to graph the equation. So x equal 4 is a vertical line going through the coordinate 4 on the x-axis. In other words, that's 4. Okay? Now, when it says x is greater than, which side do I shade?
The right.
Okay? I'm going to shade that right side in green. This is the one time where you don't look to the y-axis because there's no y in that equation. Okay? The second one, y is greater than or equal to 0. What does y equals 0 look like?
It's at 0.00.
The line. It's the equation of the line.
So it's horizontal.
Where? Horizontal, I got an infinite number of horizontal lines I can draw. Where's this one go?
On the x-axis?
Exactly. I'm going to use a different color for this one. Let's use blue. In other words, and this line is greater than or equal, so it's also a solid line, as opposed to a dotted line if it was just greater than. In other words, the difference between dotted lines and solid lines are whether the thing says greater than or equal or just greater than. Which side of this do I shade?
So
Y is greater than. This is one where you look to the y-axis.
Above.
Above it, exactly. In other words, all you have to do is find any point on the y-axis that's greater than 0. Well, that point's greater than 0. I don't know what that point is, but I know it's greater than 0. So I'm shading this. That's y is greater than 0, greater than or equal to 0. And now finally, let's graph that one. And what's a nice color to use? How about orange? And remember, the way to graph these is pretty much graph them as if it's an equation and then use a solid line or a dotted line appropriately. So how would you graph that equation if it said 5x plus 4y equals 40? That's in a particular friendly format where you can figure out the x-intercept and the y-intercept without even figuring out slope.
Okay.
What is the x-intercept going to be?
6. Oh wait, no, 8.
Right? So the x-intercept is going to come right there. So that point's on the graph. What's the y-intercept?
10.
Well, let's call that 10 right there. And it's a straight line. We can see it's a linear equation. It's solid because it's less than or equal. Which side of that line do I shade?
The below.
Yes. That's always your answer, above or below, except for this one. In other words, when we only had x, the answer is right or left. But if there's a y in the equation, then you want to shade below. Well, there's a point that's below, so that's the side I shade.
Okay.
It's really rather simple. You always look to the y-axis. Now, what's the region that's common to all three of those?
That triangle in the middle, kind of.
Like that.
Yeah.
Okay. And that's the answer to that. Sketch the solution. Now, when they talk about solutions to linear inequalities like this, you kind of have to sketch it. It's not easy to describe numerically. How would I describe that? When I just asked you, you couldn't describe it numerically. I wouldn't be able to either. I would say the triangle whose vertices are, and I'd give you three vertices. One of them being that vertex, one of them being that vertex, and one of them being that vertex. And that would be one way of describing it. But usually the way you describe them is by a graph. That's the most efficient way to describe a solution set to linear inequalities,
Okay.
as opposed to a number. It'd be very difficult with a number line to do it.
Right.
I don't want to spend all of our time on these, but let's do at least one more. Make sure you know how to do it.
Okay.
We can do both of them if you feel the need. Where do I start here?
So it's a vertical line at 0.
Which side?
Um, left, I think.
What's that say?
Oh,
It says greater
so
than.
x. So right.
So you look to the x-axis, since it's a vertical line. There's no talking vertical or up, above, or below doesn't make sense. So you have to say right or left here. Well, you just go to the x-axis, you find a point to the right of that line. Got to be greater than.
Okay. Yeah.
Next one. These are simple. You just do them step by step.
So horizontal line at 0 and shade above.
Okay. What's the third one? What does that say? X is less than 6?
So point at negative, or I don't know where I got -6.
Okay.
And then
Vertical line at x equals 6.
right.
Which side?
The left.
And notice that I do the whole left side. I
Right.
don't just do the side that's going to have red, blue, and orange. Just to be clear, you're doing the entire left side. Then we're going to figure out what has all four colors in it. And finally, this last equation, let's do that in green. I can't quite read that. Is that x minus 3y is greater than or equal to minus 12? Is that what that's?
Yeah.
Okay, how you graph that?
So,
Notice it's in standard format.
Right. Yeah. So
do those intercepts. And 12 is divisible by 1, and it's also divisible by 3. As long as that is true, that's always the easiest way to graph these. In other words, if this was a 5 right here in front of the x, then it wouldn't be so easy, because then you'd be trying to graph a point that was 12/5. That's not easy to do. But as long as it's a whole number, by far the easiest way to graph it is to find the intercepts. What's the x-intercept?
-12.
The y-intercept?
4.
There's that line. Now, which side of that line are we on? Now, that brings up an interesting problem. Because we graphed it using the intercepts, we don't know which side of that line we're on. In other words, we kind of, I forgot this. I don't know how come we didn't run into it on that previous problem. Maybe we did and I just didn't notice it. I'll bet we did. Yeah. I guessed right on the previous problem. But notice, in order to figure out which side to shade, you got to get this thing in terms of y or x. But we know what y looks like. Solve inequality for y. Let's start there. Got what?
So, move the x over, so subtract x on both sides, so -3y is greater than or equal to -x minus 12.
Okay, now what?
And then divide by -3.
Okay, tell me the next
So y is greater than or equal to...
I'm dividing an inequality by a negative number. I got to reverse the sign.
Oh, okay.
Every time.
Okay, so is less than or equal to negative or 3x?
Well, I'm dividing by 3. There's a 1 there already.
Oh, so 1 over 3x plus 4.
Now that is that line. Notice that line has a positive slope. It's flat, so 1/3 makes sense, and it goes through the 4-intercept. Now, because we have it in that format, we know exactly which side to shade. Which side?
Below.
In other words, always look to the y-axis. But in order to be able to look to the y-axis, you've got to put it so y is all on one side by itself. Notice that it wasn't so easy to tell which side to shade when I had it like that. It was easy to graph, but it wasn't so easy to tell which side.
Right.
Whereas once we converted it into y equals mx plus b format, so that y was all on one side by itself, now we were easily able to tell which side to shade. So now our area is the area that has all four colors in it, which looks to me like correct?
Yeah.
I think so. That's x greater than 0. It's y greater than 0. It's x less than 6. And it's y less than that green line. So that's our solution set. Solid lines around it, because everything in this problem was greater than or equal to, or less than or equal to. There was no missing equal signs. If there were, one of these would be a dotted line. It would look kind of like that. An edge would look like that.
Yeah.
If it just said y is greater than 0. Then that bottom side of that trapezoid would be a dotted line. All right. Think you understand how to do those?
Yeah.
Let's skip number 9, even though number 9 has an extra special thing about it. It's got an absolute value. Let's not skip it. It's only 2 equations. It's easy enough to graph these. Oops. First one. How do I graph that?
So it's going to be a dotted line because of the no equal sign.
Okay, good. What's
And then
the absolute value function look like?
like a V.
If I said to you y equals absolute value of x, you're right. It looks like a V, right?
Yeah.
Okay. Well, this is the absolute value function that's got 3 transformations. 4. It's got a reflection, the minus sign in front of the 2. The 2 is a vertical stretch factor. The 3 is what?
Part of a point because
It means it's being horizontally shifted 3 units to the right. And the plus 6 means it's being vertically shifted 6 units up. Okay, so I'm going to do each of those transformations one step at a time. The minus makes it look like that. You with me?
yeah.
The 2 is a vertical stretch, makes it steeper. Looks like that. The 3 means that it moves 3 units to the right. And now it looks like that. And the plus 6 means that it moves 6 units up. And I always use my vertex here as the point that I'm moving around. Okay?
Okay.
Now, which side of that are we on?
The right side?
Above or below?
Above.
Don't say right or left unless it's an x equals something or an x greater than something. If there is a y in the equation, say above or below. What's that sign right there?
So less than.
Okay, so here's what I do. I go to the y-axis, I find a point that's less than this function. Well, there's a point. That tells me which side to shade. Below.
Okay.
Okay. Now, let me erase this and get us started with the proper first line. It's about there. And as you correctly pointed out, it's a dotted line, not a solid line. Now I'm approximating here. I'm not figuring out any x-intercepts or anything. Just know that I want to shade that part of it. Okay?
Okay.
Let's look at that equation. Solid line or dotted line?
Solid.
How are we going to graph this?
So the starting point is at +4.
No, it isn't.
Right.
Oddly enough. In other words, the easiest way to graph this is to put it in y equals mx plus b format. But in order to do that, you have to distribute that minus 2/3 there. Then I will have it in y equal mx plus b format, and I can know where to begin. I know it's a straight line. I just can't tell from that graph where it begins. And I don't want to go through the whole transformation because it's easier to just solve it. Okay? So if I solve that, I get minus 2/3 x plus 4/3 plus 4. Now, when I combine the numbers, I get 5 1/3. Different y-intercept altogether. That last number is not the y-intercept in this format. You've got to get that thing into y equal mx plus b format for that to be b. 4 was not b, 5 1/3 is. So I know at least where to plot it. There's about 5 1/3. Use the pink here. So that's the y-intercept. What's the slope?
Down 2 over 3.
Over which way?
Either way.
Actually not. If I go down 2 and go left 3, I've got a positive slope.
Oh, right. This isn't an absolute line.
I know why the school system in Colorado teaches everybody that terminology. Without fail, every single student I get, 100% of them, uses the terminology up and over or down and over. That's not enough. If you're going to go down, then you got to go to the right. It's not over, it's to the right. If you have a positive slope, then you got to go down and over to the left. You just got to make sure you end up with the right slope, the right sign on the slope. Okay? So I'm going to go down 2 over 3. That'll put that point at about there. Draw a straight line through that. Which side of that do we shade?
Above.
Correct. Always look to that. That tells you above. That is a solid line, so we're going to shade this part right here. And that makes the common area right there. Now, there is some interesting questions here that one could ask. For example, is that point in our area?
No.
No, it is not. Is this point in our area?
No.
is this point in our area?
Yes.
Very good. That's a difficult distinction to make when you're talking about these. If you're on the dotted line, you are not in the area. You got to be inside those two dotted lines. All right. Gosh, we don't have a headache when this session is over. What kind of phone did your mom use?
Samsung.
Oh. Because usually this is what happens when somebody uses an iPhone and sends it as a small image. If you use an iPhone, you have to send it as a large image, which means this is probably blurry just because she wasn't holding the phone still enough.
Yeah.
In other words, you got to hold it really still to get a nice crisp image. Of course, that depends on what kind of Samsung she has. She might have an old one with an old camera. And then sometimes this is as good as you can get with an older camera. Okay, let's see. If the inequality which represents B, and they're referring to this picture over here, is y is less than x. See why that is the graph of y is less than x? Not that obvious. Hold on a second. What's going on here? I guess I already have it. No, I don't have it. Just a second here. In other words, how do you graph y equal x?
Zero, zero.
Oh, it goes through that.
Nothing.
What's the slope?
Up one to the right one.
So it's a 45-degree slope. So that's what that line graphs at. And that's why we're looking at that line that looks like line B. And it's a dotted line because it's less than x. And so we're graphing, hold on. Tutoring? Bye-bye. So which side of that line do we shade?
Below.
Correct. As they have done there.
Right.
And then which two regions show the shading for that inequality? What's the answer to their question?
Region 2 and region 3.
Correct. Write a system of linear inequalities which are shown in this graph. Okay, well, they've given us one of them. Y is less than x. What's the other one? In other words, what's the equation of that dotted line? What's the equation of it? And then we'll figure out what the inequality of it is. What's B?
3.
What's the slope?
Down 3, right 3.
Which means the slope is 1, -1. So negative 1x plus 3 would be the equation of that line. Give me the inequality of that line.
So y is greater than negative x plus 3.
Correct. Which is regions what?
1 and 2.
Okay. In other words, by looking at the graph, we can come up with the inequality. So we've answered 10 and 11. Find the exact location of P. How do you do that?
So you can plug in a point to one of those equations or both of the equations.
How do you find out where two lines cross? In other words, here's what I'm looking at if I'm looking at equations. This equation is y equals minus x plus 3. This equation is y equal x. Solve that system of equations and you will have the coordinates of point P.
Okay.
How do you solve that system of equations?
So you can do substitution. So you can plug in negative x plus 3 into the negative y below.
That's not negative y. That's what that is.
Oh, sorry, that's y.
Okay, so let's do that. Minus x plus 3 equals x. Now solve that.
So 3 equals 2x, so then divide that. So x is 3 over 2.
Oops, excuse me. I'll never say another word about basic math skills. So what's y?
So then so
What's the second equation we came up
So y is negative, or
with? Y equals x.
so 3 over 2.
Don't make it more complicated than it is. Y equals x. X equals 3 over 2. Therefore, y is 3 over 2. So the coordinates of that point are 3 halves, comma, 3 halves. In other words, the way you solve where two lines cross is by solving the system of equations. However you want. You can do it by substitution or elimination. But wherever they cross is going to be the solution of that system of equations.
Okay.
Okay. Now, is the point 2 comma 5 a solution to the inequality? Well, let's see. The joint region is that region there, correct?
Correct.
We know the point right there is 3 halves, comma 3 halves. So the point 2 comma 5 is definitely to the right of P, and it's above P. So it's somewhere in there. This point right here, 2 comma 5,
Right.
is that in the region?
No, it's not.
No. Did we graph this region correctly? No, we did not. We didn't graph that part correct. Yes, we did. Yeah, we were greater than that line, and the joint region was where we were greater than that line, but less than the other line. So, yeah, that what I've drawn in black here is the proper region, and that point is outside that region.
Right.
This point here, 2 comma 5. So, where that's that point right there. Okay, the point that I've labeled 3/2 is that point there. But clearly,
Right.
2 comma 5 is outside that, although it's not maybe so clear that it is. What if they'd have said 2 comma 3? Well, I'm not so sure whether I'm above that slanted line or not. Well, if the y coordinate's greater than the x coordinate, I'm above that line, right?
Yeah.
If the y coordinate is equal to the x coordinate, I'm on that line. That line is y equal x. That line with positive slope there. Okay? So as long as the y coordinate is bigger than the x coordinate, then I'm above that line. And this region is below that line. The line I'm talking about is that line right there.
Right.
2 comma 5 is above that line, and we need to be below that line because the inequality was y is less than x. So this y coordinate, at least at a very minimum, has to be less than the x coordinate for you to have any chance of being in that region.
Okay.
Is that all we got?
Yeah.
Okay. I'll give you two choices. We can go to the end of the hour and go back over your last material and finish those 2 word problems we didn't get to. Or if you feel comfortable, you ready to be done, that's fine also. I only charge for the amount of time that we use. I don't charge for a full hour if we don't use it.
Okay. Yeah. So I don't have the paper that we did last time because I turned it in yesterday.
Okay.
So I think it'll be good to stop.
Okay. Good to go.
All right.
Demetrius, I'll talk to you next week.
Yep. You too.
All right. Bye-bye.
Thank you.